idea. If you describe to me how we find volume, how would you describe to me how we find volume? In general, if I ask you to find the volume of a figure, how do you think about that? Length times width times height. How about we think of volume this way? The area of the base multiplied by the height. Is everybody okay with that? Yeah. So when we were going through our area section, this is a piece that I left out simply because I felt this could be a little bit more challenging for our test, but we choose to bring it back in this time. And it says region R is the base of a solid. So this guy right here. So I'm gonna kind of color that in blue. Okay, there we go. And it says for the solid at each x, the cross section perpendicular to the x-axis is a square. Find the volume of that solid. Now I'm going to do a poor job of drawing this, and I'm going to let you know right away. But on the AP exam, this would be a free response question. You would be given 3 points for each part, for a total of 9. So this would be points 7, 8, and 9. And here's what it's saying. This piece right to you right now, you see 2 dimensions, right? It actually has 3 dimensions. It has something coming up at you. If you were to slice that, you get, like picture like slicing a ham or something, right? And when you slice it, if you were to look at the side of it, it would look like a square. So I'm going to try to draw a few of these to the best of my ability, and I'm going to do a poor job. So like it's coming up at you there. Here's another one. Can people kind of see what's happening here? Can you see these things giving height to the object? So it's not that bad to try to figure this out. What we have to do is we just have to figure out how we find the volume of one of these things. So I'm gonna put one of those right down here, and I'm going to use your guys' idea that you came up with. Thickness dx or dy? Dx. Okay. It's a square. How do you find the area of a square? Base times height. So we got to think about the length of this base right here. The length of that base is the distance from here to here. We call this top function G. We call the bottom function F. Do you remember what we said was the distance from here to here? How do we do that? How do we find the distance from here to here? Top minus bottom. G of x minus f of x. Agreed? Good. G of x minus f of x. Tell me, if it's a square, what do you know about the sides? So then what is this side going to be? G of x minus f of x. So if you find the volume of all that, you multiply it all together, right? So you get the integral of g of x minus f of x, that quantity squared, dx. You do need bounds. Remember yesterday, we called this point here A, and we called this point here B. Everybody good with that? And so we'll simply call this A and this B. Now, would everybody here be able to type that in their calculator then? Yeah, you would. And then you'd be good to go. So this whole like having the base as a solid and then raising height off of it, that's something that definitely happens. Okay. Oh no. Okay, flip it over. Let's look at this one. It says that R is the base of a solid again. For the solid at each x, the cross-section perpendicular to the x-axis is an isosceles right triangle where one of the legs lies within the region. I'm just trying to help you interpret it. Again, I want you to realize that when you see these questions on a test, I don't want you to freak out like, hey, I've never seen this before. This is my region right here. Okay? If I cut it, what shape do I get? An isosceles right triangle. What do you know is true about an isosceles right triangle? 90 degrees and 45, 45. And two legs are the same. So it says if you were to slice it, okay, you would get this triangular shape. And it says one of the legs lies within the region. So it's not the hypotenuse is face down. It's one of the legs is face down. You see that? Okay, so let's try that. We're going to take this shape. What's the thickness, dx or dy? Dx, very good. Blake, can you describe for me again how you found this distance right here? Top minus bottom. We said that the top in this case was f and the bottom was g. So this is going to be f of x minus g of x. It's an isosceles right triangle. So what do you know about this side? It's the same. Now if you want to find the area of a triangle, what's the formula? Good. So we have the integral of base times height divided by 2. And our values were from 0 to pi. And in this situation, this would be a non-calculator problem. And so that's why they would say write, but do not evaluate an expression for the volume of the solid. Okay, and that's where they come up with that. Not too bad. Just want you to have a reference because when we actually look at the free response questions, I want you to feel like you got a fighting chance. My good friend Jada, everybody say hi, Jada. Jada confessed something to me today. Can I speak what you confessed? She confessed that she has not retained as much calculus as she hoped to. I find that the calculus that people retain is actually, in many ways, this section right here. I believe that this will go quite well for you. The most common asked question on the free response section is problems regarding motion. Second most common would be the area problems. So we covered area. Let's go to motion. Please take out your calculator. It says a particle moves across the x-axis with velocity given by this function for time 0 to 8, and the particle is at position x equals 3 at time equals 0. It says determine the velocity of the particle. Anybody got an idea for what I'll do? Plug in 3. They give you the velocity function. And sometimes you'll get something that easy on the exam. So we do v of 3. There's a couple ways you could do that. First of all, I recognize that this is a calculator problem, so I'm going to make sure that I plug into these pieces the function, which is sine of x minus pi, parentheses, divided by x. Anybody got an idea how I'm going to figure out the velocity at 3 then? Table, or you could do value, either one. I'll go to my table, is that that's what you've said first, and I just simply plug in 3, and I get negative 8 e to the negative 4. Anybody know what that value is?
I got negative 0.0.
Oh, I'm sorry, I must be working in degrees because I was teaching pre-calculus. Sorry about that. Working on vectors today, and we give our answers in degrees. Go back to my table. 3, I get negative 0.047. We all good? So negative 0.047. There are no labels, but if there were, we should put them. Always 3 decimal places. Somebody tell me how I determine acceleration. Derivative. What do I press? So I can calculate number 6. And I get my function, and I want to find the derivative at time 3. So v prime of 3, and I want to be clear that this is what you communicate on the AP exam. You said that in order to determine acceleration, you did v prime of 3, which is equal to then a of 3, which we said is 0.345. If I ask questions like this on a test, can you guys get these right? Don't shake your head at me. These are a must. You've done them once before. This was chapter 5. Is the particle speeding up or slowing down at time equals 3? Do you remember our rule of thumb if it's speeding up or if it's slowing down? We talked about it. Anybody remember? We look at velocity and acceleration. If velocity and acceleration are both positive or both negative, then it's speeding up. If velocity and acceleration are opposite signs, then it's slowing down. Do you remember us talking about that a little bit? Griff says he does. So it says at time 3, and it says to justify your answer. This is what you'll have to write on the AP exam. And trust me, these are the problems when I go back and read through your work, and I know we did this exact problem, not only on your test, but also in the review. And then people don't get this. This is what really drives a teacher nuts. So it says justify your answer. First of all, let's look at V of 3 and A of 3. Are the signs the same or different? Different. So is it speeding up or slowing down? The particle is slowing down. Because A of 3 and V of 3 are different signs. If you said speeding up, you would say because A of 3 and V of 3 are same signs. That's simple. I promise you, on the test I give you before your AP exam class, you have to do a problem like this and do it well. You can do this. When does the particle change direction? Remember what tells us when a particle changes direction? My velocity. Say my velocity. Is my velocity positive or negative? How about now? Negative. If you cross over from positive to negative, what number do you have to cross over? 0. So we want to determine when V of t is equal to 0. I look at my calculator. I'm going to change my window so I can see better. I'm going to take my window. I'm going to create my y minimum to be -2 and +2. And I look at my graph. And I'm looking between 0 and 8. Does this thing ever cross the x-axis between 0 and 8? Yes. How would I find that spot? Second, calculate 0. I choose number 2. Left bound, enter. Right bound, enter. Enter on guess. And I get time is equal to 3.141. There's another spot. How am I going to find that? Same thing. Second, calculate, and I choose number 2. I move over. I do the left bound, and I do the right bound. Enter on guess, and I get 6.28. Those are the 2 spots where it changes direction. Can somebody tell me what is our formula for determining position? Talked about it multiple times now. Start plus displacement. Take a minute and a half, see if you could. All right, let's talk about, see where you got. Start plus displacement. What's the start? It starts at 3 plus displacement. You do the integral, 0 to 5 of v of t dt. The way I calculate integral 0 to 5 v of t dt is I go to my calculator. I go second calculate. I choose number 7. Go 0, enter 5, enter. And you can see I get negative 1.549. 1.549. Add those together. 3 plus negative 1.549. And we get 1.451. That's its current location. Total distance traveled. Oh no. What's the difference between displacement and distance? Very good.
Displacement is like if you travel far and then come back.
Right, so you're trying to model this. If it's 15 feet to the door and I walk here and I return, what's my displacement? What is my distance? 30. So what do you have to do? Absolute value. Do you remember that? We do integral from 1 to 6 of the absolute value of v of t dt. Let us calculate that. We go into y equals. How do I get absolute value? Give me some ideas. I could do math, or I could do this. Catalog, and I could grab my absolute value, and you could grab y sub 1 and place it there. Vars, y vars, function, y sub 1. Close the parenthesis. There you have it. And if you go to the top, take that enter off, and now you're graphing the absolute value of y sub 1. See that option? You're going to want to make use of that. Second, calculate, number 7. Look at when it graphs the function. See how it keeps it all above the x-axis? It's kind of cool looking. You're going to go from 1 to 6, and it gives you a value of 1.333. Everything I'm writing down is the work that you will want to show on your test as well as on the AP exam. 2 more questions. Find the average velocity. True or false? We are given the velocity function. True. How do you find the average value of a function? We did it just the other day. Do you remember? Very good. 1 over b minus a, integral a to b of the function. So if you want to know the average velocity, you do 1 over 8 of 0 to 8 of the velocity function. That's the next piece that we will execute. So as I go to my calculator, you tell me which function do I want to use, 1 or 2. I use 1. I'll take the bottom one off. Second, calculate, and I use number 7. What are my bounds that I choose to use? 0 and 8. True or false? My answer is negative 1.574. What do I have to do? Divide it by 8. I think if you actually write your answer like that, they give you full credit. Now, I've never been a scorer, but I've talked with people who have, and I think that they give you credit for that. But let's give them a decimal. Anyways, we're going to divide that by 8, and we get negative 0.19675. There you go. And for this, the last kind of question, find the average acceleration. Average acceleration. If it said find the instantaneous acceleration, what would I do? If the problem said find the acceleration, what do? Take the derivative. If it says average acceleration, we have to do slope. Remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if you want to find the average acceleration, find the slope of the velocity, and that will give you the acceleration. Can somebody tell me, how do I determine v of 8? Look at the table, second table. I plug in 8, enter. And I get negative 0.1237. I'll plug in 0, and it says error. Uh-oh. What's going on? Oh, that's because there's a 0 here. So it doesn't work. My bad. But this is how you would set it up. But it looks like 0 is not part of its original domain. My bad. Sorry about that. Will you forgive me? Thank you. Flip it over. What's different about this problem? You can't use a calculator. Do you think you could do it if you couldn't use a calculator? She's saying no. Let's see. Let's do it together. It says determine when the particle changes direction. Can you remember from what we just talked about? When does the particle change direction? When? Sign changes for velocity. We're going to find out where does the velocity change sign, right? Where does the velocity change sign? When is velocity equal to 0? So let's look at where the velocity changes sign. We have 2 roots of x minus 6. It says that's the velocity function. Do you guys know any math to figure out when this is equal to 0? Could you solve that if you saw that on the test? What would you do? Add 6, divide by 2, you get square root of x is equal to 3. Then what would you do? And you get x is 9. Now, you do need to show that it changes sign, so you have to show it's negative and then positive. So let's just sketch a graph. What is the graph of 2 roots of x? What does the graph of the square root of x look like? Yeah, it looks like that. And it starts down at negative 6. So if you start at negative 6 and you show it changes at 9, you're good. Negative to positive. We have to show it changes sign. You could also test a number on either side. Good with that? Determine the total distance the particle travels for the time interval 0 to 9. I don't want to do that. You're not going to be asked that question. Let's determine the displacement. I haven't seen that question asked in that context yet. We're going to change it to displacement. Determine the displacement of the particle. How do we determine displacement? Integral 0 to 9 of? Yep, v of t dt. Or in other words, the integral 0 to 9 of 2 roots of x minus 6 dx. Oh, do you know how to do that? What's the antiderivative of 2 roots of x? Let's see, that's 0 to 9 of 2x to the 1/2 minus 6 dx. Antiderivative of 2 roots of x, or 2x to the 1/2, you said 2x to the 3/2 divided by 3/2 or multiplied by? Yeah, so 4 over 3 x to the 3/2. And then what's the antiderivative of 6? 6x. And we're going to evaluate it at 9 and at 0. At 9 and at 0. So if you plug in 0, what do you get? We get 0. We plug in 9. What's the square root of 9? To the 3rd? Divided by 3 times 4? 36. Minus 6 times 9? 54. What is 36 minus 54? Negative 18. Okay, let me show you. So 9 to the 3/2. You can either cube 9 and then square root, or you can take the square root of 9 and then cube it. Either way, it's up to you. So, Allie, I don't like to take 9 and cube it. I like to take 9 and take the square root. What's the square root of 9? Then cube it. Oh, that wouldn't work out very well. You see, right? So right, but I just want to be clear. The AP exam, if they were to have the bound be 7, it would be a calculator problem at that point.
So they give you like.
They will give you a nice number. Yep, in just about all circumstances. Yep. Yep. It says find the position of the particle at time equals 4. Let's just do time equals 9. Remember, how do we find position again? How do we find position again? Start plus displacement. So where was the start? Yeah, it says that it starts at -2. Okay? So that means -2 plus the displacement, which is the integral from 0 to 9 of v of t dt. Do we already know the integral from 0 to 9 of v of t dt? What is it? It's -18. So -2 plus -18 is -20.
Okay, so what if we get an answer wrong for B, but we set up the next problem correctly? Do we get partial credit?
If you need they try to make it so you don't need the answer from the previous problem in order to develop the next.
Oh.
They try to make them independent. Look at letter D. Find the average velocity. True or false? We're given the velocity function. True. What is the formula for the average value of a function again? 1 over b minus a times the integral from a to b of the function. It says from 0 to 9. Do we already know the integral from 0 to 9? What is the integral from 0 to 9? It is -18. So what are we going to multiply by -18? What is 1 over b minus a? 1/9. And what is 1/9 times -18? -2. Find the average acceleration from 1 to 4. True or false? I'm given the acceleration function. False. True or false? The acceleration function is the derivative of the velocity function. I'm not finding the exact, I'm finding the average. So I need v of 4 minus v of 1 over 4 minus 1. My good friend Allie is going to take us through this one because she knows exactly what she's doing here. Allie, what's the bottom number give us? See, you can do the calculation. Now let's plug in 4. It says velocity, so if I plug in 4, you get -2 minus, and then if I plug in 1, what do you get if you plug in 1? -4. So -2 minus -4, so that would be 2/3. 2/3 is your average acceleration. We're almost done. Find the acceleration of the particle at time equals 4. How does acceleration compare to velocity? Derivative. Can you guys find the derivative of the velocity function? Somebody please tell me what's the derivative of 2 roots of x? Everybody agree it's 1 over the root of x? What's the derivative of 6? 0. So you can see they've given you a nice 1 here. It's just 1 over the root of x. And I want to find that at time 4. So that means that v prime of 4 is equal to, what's 1 over the square root of 4? 1 over 2. It says, is the particle speeding up or slowing down at time equals 4? Well, we know that the acceleration at time 4, what did we determine as the acceleration at time 4? 1/2. How would I determine the velocity at time 4? Plug it in. If we plug 4 in here, the square root of 4 is, times 2 is, minus 6 is, -2. So if the acceleration is 1/2 and the velocity is -2, is the particle slowing up? Or is it slowing down, or is it speeding up? The particle is slowing down. It says just by your answer, we must say particle is slowing down because A of 4 and B of 4 are different signs. I bet you understood that one